All right, so the next booklet brings back identities, but now we have more from the formula sheet that we can use. So all of our concepts are going to be exactly the same as the last Proving Identities booklet earlier in the unit, but now we're just going to be using all of these guys on top of everything else we discussed in that booklet. So we're talking factoring, common denominators, using using tan as sine over cos, using cotan as cos over sine. All those little things are still going to pop up as we go through these questions. Okay, so it's usually good to put everything in terms of sine and cosine. So before we deal with the more complicated right-hand side, I'm just going to change the left-hand side to be in terms of sine and cosine. So we're going to go cos x over sine x for cotan minus 1 over sine x. That is a common denominator, so I can put that as cos x minus 1 over sine x. And I will leave that side B for now. Maybe we need to deal with it a little bit more later, but for now I'm just going to leave it as is. On the right-hand side, yes, I have sine and cosine, but if you notice, I have cos double x, sine double x, which means when I get my formula sheet out, I have double angles that I can use. Let's take a look at the denominator first, because you may notice that cosine has 3 options, and it might be better for us to pause for now and wait to decide what is our best course of action for the numerator. So I'm going to leave that, because I don't know which one I should choose just yet, but sine only has 1 option. So that makes our life a little easier, because I'm just going to plug that directly in. I get 2 sine x cos x minus sine x. In the denominator, looking to factor or doing something along those lines, I see that there's a GCF of sine. So I get cos 2x minus cos x on top. Take the sine x out of both, so that divides out here. You're left with 2 cos x minus 1. Sine x coming out leaves you with 2 cos x minus 1. Now my goal when I see this is I'm guessing I'm going to have to cancel either the sine or the 2 cos x minus 1. Well, on top I already have minus cosine x. I probably don't want an equation that has cos and sine, because that's just going to give me too many terms on top. I don't want cos and sine, that's too much. If I put sine on top, what's it going to do with cos? It can't really combine to do anything. It won't be able to factor, nothing like that. If I put 2 cos squared alpha minus 1, in this case x, I would have a cos squared, a 1, and a cos. Well, I'd rather have one function on top, so everything is in terms of cos, rather than sine and cosine from there, or sine and cosine from there. So what I'm going to do is I'm going to take cos 2 is equal to 2 cos squared x minus 1. So that's this puzzle piece here, minus cos x. Okay, so again, I chose this formula here. So now everything in the numerator is in terms of cosine. That seems a little bit better in terms of working towards canceling the bottom, because now if I go from highest to lowest, I got cos squared x minus cos x minus 1. And now in the top portion, I can factor. If I would have had sine squared on top and cos x, I couldn't have done anything with that. So that is why I chose to substitute in with cos squared x. I end up with crisscross to get 2 cos x plus 1. And cos x minus 1. Then on the bottom, I get sine x times 2 cos x minus 1. All right, I'm just realizing that I may have made a small sign mistake. Apologies for that. Let me just quickly double check to see the version that you guys have. Okay, apologies guys. This is not going to change our question up too much. Hopefully you noticed it throughout the video. But this is a plus sign there. So that's a plus sign here throughout the question. In terms of how we answered it and how we evaluated it, it really doesn't change anything actually at all. And the reason I noticed it, here's my troubleshooting, as I realized I made the mistake there, this plus sign throughout wasn't going to cancel here, right? Because of the minus sign. So now that it has a plus sign, I can cancel it out. I still go through the process exactly the same. I'm still looking to factor on top so then I can cancel out that bracket. It just ended up being a plus instead of a minus. So you guys had that in your booklet already. Just make the change here as I went through. Since that canceled out, I am now left with cos x minus 1 on top over sine x. And now my left-hand side equals my right-hand side, and I have proven the identity. Not a heck of a lot changed in this question versus other questions we've had with identities. The big difference obviously now is that we just have more formulas to choose from. More often than not, they like to choose from the double angle stuff. So if I'm looking at those, I just have to evaluate, right? Sine 2 alpha only had one option, which is why I substituted in with 2 sine cos x. I took a GCF out, and then I noticed that this bracket or maybe this bracket could cancel. I wasn't sure which one. The reason I chose out of the 3 cos squared x was because I wanted to have only cosines on top, which allowed me to factor. And once I factored, I was able to cancel out one of my brackets on the bottom.